So, hello. I hope you are not too much exhausted already, because this is only the first day of this conference, and I would like to welcome you on this talk, Take Your Test to the Cloud with Testkube. But before we dive in, I will need small help from your side, so I will know a little bit more who is sitting here in my audience. Please raise your hand in case your company already does or would like to do end-to-end testing of your product to better control the quality. So few people is testing the quality, okay, and I guess that the second question will be much harder. Who of you already knows something about Testkube? Perfect. So I guess most of you is at the right place because the rest of the talk will be all about testing, especially end-to-end testing. I think it's important because with it we will have a confidence that what we ship to the production is actually working. And I would like to talk about Testkube, which is a tool which we are using in my company, because I guess that most of our application workload is currently already running in clouds, inside Kubernetes clusters, but it is usually connected with some challenges. So this talk will be about the challenges, we have to deal with them, and how Testkube can help us at least with few of them. Let me introduce myself. My name is Tomáš Hradec. At the moment I am working for Atacama as a senior staff engineer, so don't worry, this is not any type of sales pitch. This talk is really based on our personal experience with this tool, how we are using it and how it helped us. So for the beginning, let's take a step back and let's look how the traditional end-to-end testing usually looks like. On one side, we have a Kubernetes cluster when we are running our product, and because this product was built with help of microservice architecture, it consists of multiple more or less independent services. There are some backends, some frontends, and because we are developers and we want to have much more fun, different teams can choose to use different technology stacks. So we usually end up in a situation that one service is implemented in Java, another one can be implemented in Python, the front end naturally in JavaScript or TypeScript. On the other side, for each of these services, there are usually some CI/CD pipelines, and it doesn't matter if they are implemented with GitHub Actions, GitLab, Jenkins, or whatever is your favorite tool. The responsibility of this pipeline is usually building the service, deploying the service, and if you do so, they often contains the steps responsible for orchestrating your end-to-end tests. So far, so good. Personally, I have seen similar solution many times, and it works more or less pretty well, unfortunately, until it doesn't, because there are some inherent limitations of such solution which can cause some friction, which can slow us down, and let's look at few of the issues connected with these solutions. These issues, of course, more obvious once our system is more complex, once the requirements on the system, how we want to test this, are more complex. Each of the testing tools came with its own complexity, its own way how to trigger test, how to pass required configuration. Often we have to solve issues connected with different versions, even of the same test, because not all versions are backward compatible, and this complexity can be multiplied when we consider complexity connected with implementing these steps in our CI/CD pipeline. We are usually able to somehow deal with these issues in context of one team who is responsible for one service or just few of services. But consider the situation when because I did some change on the cluster, I would like to trigger all smoke tests of all currently deployed components, all currently deployed services, not only them, which I own, because I want to verify that I didn't break something. In such case, relatively simple requirement can be hard to fulfill because of different testing tools that are used across different teams. A similar situation is there when we want to just check if our system is in good shape or not, if we are green or not, because each of these testing frameworks which we can use has pretty good reporting capabilities on its own. But once we want to have some system-wide overview around all of our system, it's much more complex to gain all these necessary information. Oftentimes, the execution of the end-to-end test is very tightly tied just to the pipeline itself. It's some step inside the pipeline. But the impulses, the reasons to trigger my test came from elsewhere. For example, I would like to just evaluate some of my theory, and I would like just to quickly trigger my end-to-end test from a local machine, and I don't want to be slowed down and waiting once the pipeline machinery starts. Another example can be, if I would use GitOps, maybe it's a good idea to trigger the test execution once the synchronization of my Argo CD application is done. But such event is asynchronous to the pipeline step itself, and again, to fulfill such requirement can be complex. The test, because they are running inside the pipeline, can only access services which are exposed outside of the cluster. But often we want to also test on the internal application, the backend services which are consumed only inside in the cluster and are not exposed outside. In such case, we usually have only two options: don't test them at all, or expose such services externally. Well, I guess that neither of these options is optimal, because exposing some internal service externally can have some security concerns. Oftentimes, scaling can be an issue. The pipeline infrastructure itself usually is not prepared if we want to run too low, to trigger some performance test. The infrastructure of the pipeline is usually not prepared to handle such massive load. Or different example is, just imagine that I'm operating a very successful product around the world, so I have large fleet of Kubernetes clusters, and I would like to trigger the test against all of them. In such case, again, the pipeline infrastructure itself can be a bottleneck for me, which is definitely not what we would like. Last and not least, there can be an issue with versioning of the test, because the version of the test should match the version of currently deployed service, but the life cycle of those is disconnected. One lives in the cluster, one lives in the pipeline, and in such case, if the version doesn't match, I can have false positive results or inaccurate results. I am pretty sure you would be able to name your own issues connected with end-to-end testing, depending on tooling what you are using, architecture in your company, and team structure. It would be great if there would be some tool which can help us to solve at least some of these issues. Unfortunately, the CNCF landscape is pretty huge, so it can be easily overlooked. I will give you some time, maybe you will be able to find it. I guess that most of you already see it, so just for the record, it's here and it's Testkube. So what is Testkube? Testkube is a test orchestration and execution framework. Its goal is not to replace your currently testing framework which you are using. Its goal is not to make you rewrite your test. Its goal is really only make you to help to execute your test, to manage the results of your test, help you with orchestration of the necessary tooling. It's integrated very well with most of the currently used test frameworks. There is support for API testing in Postman or SOAP UI. For UI tests, there is support for Playwright, Selenium. definitely for backend testing, JUnit, PyTest. It's supported out of the box. Or if you would like to do performance testing, tools like Gatling, JMeter, K6 are also available. The list of supported frameworks is long and extensive, and even if you are using something more special or custom, homemade, the integration with Testkube is usually possible. Testkube, I would say, is so-called first-class Kubernetes citizen. It was built with cloud-native principle in mind. It defines several custom Kubernetes resources which represent your test scenarios, which represents the individual execution results. It works as Kubernetes operator, so it allows you to manage even your test as any other application-related manifest which is deployed inside your Kubernetes cluster. It's open source. As we already saw, it's part of CNCF landscape, but it also brings the enterprise commercial versions, so there is some nice additional enterprise features if needed, but personally I have experience only with the open source version. I have to say that whenever I need some help, I have some questions, the maintainers, the community around the Testkube was very responsive and helpful. Testkube doesn't try to reinvent the wheel, so it integrates with existing tools whenever it makes sense, whenever it's beneficial for us. So integrating into your CI/CD pipeline into some step is very easy, and you will find ready-to-use documentation and snippets in the documentation, just copy-paste and used. Because Testkube treats your test definition as ordinary Kubernetes object, you can define them easily declaratively, usually in YAML format, as any other application-related manifest. And what's most important, at least for me, you can manage even your test with GitOps, which is great, I would say. With Testkube, it doesn't matter what combination of testing frameworks you will use, because you will gain so-called single pane of glass, the centralized place from which you will be able to check if your system is in good shape or not, if there are some issues or not. Testkube is automatically collecting all your logs from test or reports generated during the test, which is handy during troubleshooting or debugging failures. Because Testkube schedule your test inside the cluster, you can benefit naturally from built-in Kubernetes scaling capabilities. So even your test can scale horizontally or vertically as needed, depending how complex are your test scenarios. And last but not least, there is enhanced security with using of Testkube, because tests are running inside the same Kubernetes clusters as your application workload. The test can easily access even internal services, even the backend services via local DNS names, so it's not necessary to expose them externally. I guess that the theory was enough, so let's look how to define some very simple, in this case, test scenario. For that, we are using test workflows. This is the custom resource definition. This is the basic core building blocks in Testkube, which represent our test scenario. It allows you to compose your test cases in flexible way. The test workflow can contain multiple steps, or they can even be nested together into some test workflow hierarchies in case your test scenarios are much more complex. In this simple, very simple example, we are using Carl, command line tool, to send the HTTP request to some given address, and this test pass if it returns 200, otherwise it fails. You can notice that the definition of test is very similar as definition to ordinary Kubernetes deployments. You just specify some Docker image which will be run and the command which will be executed once the test is triggered. Personally, I would recommend to keep the test definition so-called self-contained. You should not download any dependencies during runtime of the test. You should not do any unnecessary work, for example, compiling the source code in the runtime of the test, because in that case your test will be slow and we want to have the test as lightweight, as fast as possible. The second example is much more realistic. It represents the test case for some real front-end service. In this case, the tests are written in JavaScript and they are using Playwright as the testing framework. You can notice that the test use the custom Docker image, which bundle all necessary dependencies, all necessary required versions, with correct versions, and also they are bundled the source code of the test themselves. For configuration of the test, they are using familiar Kubernetes configuration construct, so the configuration is passed via config map or Kubernetes secret, as we are used to. Also, we can specify the resources, CPU limits, memory, and so on, as we are used to with any other Kubernetes workload. There is a built-in support for retry mechanism in case some temporary failures. Testkube is able to automatically retry the test, and if you specify, Testkube will automatically collect all logs and generated artifacts, as for example screenshots or videos from the UI test, which can be used later as an evidence that the test passed or for troubleshooting and debugging. Now, when we know how to define the test, we can deploy it to the cluster. For that, we can use any mechanism which we are using for deploying our application. I would personally recommend GitOps, but whatever works for you is totally fine. It's just ordinary Kubernetes manifest. For interacting with Testkube, we can use Testkube CLI. This is a command line tool which you can install alongside your other tools as kubectl, or they are also distributing Testkube CLI as Docker image, which can be handy if we want to integrate it as some step in our pipeline to trigger the tests. There are a few examples how to interact with the Testkube CLI. The first one, trigger the test by some given name and watch its progress. Below is some simplified output. You can notice that each test execution has unique ID, unique name, which can be used later for querying about the results of the test or for downloading the stored artifacts. The Testkube CLI underneath communicate with the Testkube REST API, which can be exposed via ingress, or in case it's not exposed outside of the cluster, the Testkube CLI is able to create secure communication tunnel in similar fashion as kubectl port forward will do. Testkube supports many other options. Those were just the simple one. How to trigger the test, and these are just a few examples. One common use case is that I have many tests, but only some of them are marked as the smoke test, and I want to trigger these smoke tests again when I do whatever change in my cluster. Another common use case is that I want to run my test regularly on some schedule. For that, I can use cron expression. The cron expression is defined inside the test workflow CRD. And for the scheduling of the test, the Testkube API controller will handle instead of me. Another common scenario is when we are using GitOps tool, for example Argo CD, and we would like to trigger the test after the synchronization of the application is done. For that, we can use post-synchronization hook, or there is the possibility to trigger the test execution to some Kubernetes event. For example, I want to trigger my test once the config map is modified or some secret is modified. And all of these options, how to trigger test, can be combined together so it will fulfill your needs and your specific requirement. If this is still not enough, Testkube offers the commercial version. With the commercial version, you have to decide if you will run the Testkube control plane inside your own infrastructure on premise, or you can decide to use it as a managed cloud service. The most visible feature of the commercial version is this nice UI dashboard, the unified user interface, which allows you to manage all your tests and see their results. Definitely with enterprise version, as it used to be, there is support for single sign-on and for the ability to specify some access rule and privileges. In the test workflow themselves, the commercial version unlocks the possibility for some more advanced features, for example, metrics, parameterization, or parallel step execution. Also, with the commercial version, there is the possibility for much deeper analyzing the results. So it's automatically observing the trends, and you are able to see how your test behaves or misbehaves during some longer time period. But in case that you would like to stay with the open source version, as we decided in our company, we decided to build some custom dashboard on top of our observability stack. And because we are using a GTM stack, we decided to build a Grafana dashboard, which will provide us similar, but definitely simplified developer experience with this tool. For that, we are sending the structured test execution result in JSON format to Loki. Loki serves as the data source for us, and with that we are able to build this Grafana dashboard, which is providing us the information how our test behaves during the time, some statistic, and so on. Definitely, we also want to be notified in advance in case of some failures of the test. So for that, we are using standard Prometheus alerting rules and metrics, which we are scraping from the Testkube. Well, and that's it for my side. I hope you like Testkube. I will encourage you to give it a try, because I really like how it helped us to bring some structure to our highly heterogeneous environment. And if you have some questions, I will be glad to answer them. Yeah, well, the question is, what is the benefit to use Testkube if our tests are orchestrated from the pipeline? Yeah. Correct? My question is, do you operate one service or multiple services? Multiple. So that's the benefit which I see when I have multiple services spread across multiple teams. Because usually the test orchestration is also spread across multiple pipelines, and in such case, these pipelines are owned by those teams. And even if we have some standardization inside the company, usually each pipeline is more or less unique and needs different parameters, have different conditions. With Testkube, which serves as an abstraction for test orchestration, I can easily trigger whatever test I want just by specifying the name. because Testkube encapsulates the logic needed for triggering the test. This is one benefit which I see there, and another benefit important for me is that the tests are really running inside the cluster. So when I'm operating large fleet of clusters, I am not using the pipeline infrastructure because the load is spread across each individual clusters. For example, when I have some sanity tests or smoke tests which are running repeatedly inside the cluster, in such case, the pipeline infrastructure will suffer.
Yeah, but in that case, that's also a problem because you say like, and in my case, let's say I have some service which actually managed by the teams, not on my team, let's say, but they will be somewhere else, so it will not even run on my cluster. But what you say, like, I have to then mimic them on my cluster because in that case, this runs inside my cluster. So that's going to be like extra work because then I have to mimic that test case inside my pipeline.
I probably doesn't understand the question. Can you repeat it?
Yeah, so let's say you have an external service which you connect during the testing.
Uh-huh.
You use some API-based connection.
Okay.
You get results.
Okay.
And that's process test, not process test. I mean, you can set up some quality gates there. If you say like I can use Testkube for that, but that means I have to mimic the API behavior on my end, because in that case I not go to that external service. I just run everything internally inside the cluster.
We can talk about it later because I think Testkube doesn't work as you think it works. It really just triggers the test, and in that case, it triggers inside the cluster. And from my perspective, it doesn't matter if the test is executed inside the pipeline. The main goal is that it is executed, and I have the visibility if it passed or not. And I agree that most of the time, even if when I am integrating with Testkube, one source of trigger for the test is still in the pipeline, because that's the way how I, as a developer, want to observe that the version which I am currently deploying somewhere is working or not. But benefit of Testkube is that it will allow you much more complex triggering or rules how to work with your test. For example, you can mark only some subset of your test which you would like to run on some schedule and be notified if the system start misbehaving. Sorry, I have to get closer.
So, in case of a hybrid setup where there are also on-premise and workloads that are running outside of the cluster or outside of the cloud, would Testkube be also utilized for remote execution?
Well, in fact, I have to repeat the question. The question is if some workload is running outside the cluster, if the Testkube is able to test it. Does it get it right? Okay. The tests which are executed are ordinary pods, in fact. So they can access whatever service is accessible from that cluster. If the external service is accessible from the cluster, even the test can access it. Mm-hmm.
Can you elaborate where you're storing these test workflow definitions? Like, do you have like a central repository where all of them are stored, or are they spread out across repositories? If they are in a central repository, then how do you manage changes when something needs to be adjusted?
Okay, good question. The question is how we are managing our test definition, the test workflows, if we have them centrally. No, we doesn't. We are trying to have all test definitions as close to the applications as possible. So usually even the test workflows definition are part of a Helm chart for deploying the application. So once the new version of the application is deployed, even the test workflow, which belongs to that application, to that version of the application, is deployed to a cluster. So we decoupled the responsibility to the individual teams who owns the service, because we want to have end-to-end responsibility for our teams for that.
Right, but then what is the advantage to just having like a GitLab CI or GitHub Actions YAML, which is also in the same repository? Well, what is the benefit there?
Yeah, because if I want to trigger the test, I don't have to deal what pipeline the team used, what test framework the team used. I just know that everything is abstract as the test workflow, and if I run the test workflow, it's just Testkube run test workflow, nothing more. And it doesn't matter if behind that is JUnit, PyTest, Gatling, whatever. I don't care, because the abstraction offers me only one single command.
Can you explain what is the main difference between pure Kubernetes resource job or cron job
Mm-hmm.
and the test workflow?
Yeah.
It seems really similar.
Yeah. The question was, what is the main difference between Testkube test workflow and Kubernetes job or cron job? Yes, it's similar. And in fact, when the Testkube schedules a test, it creates dynamically Kubernetes job underneath. The benefit is that Kubernetes job can be anything, but Testkube test workflow has some meaning. I know that it's test. I know how to ask about its status. I know how to ask about the last 10 results, and so on. So that's just some higher abstraction. Because yes, at the end of the day, everything is pod, but I have some higher abstraction which I can use for working with it. So it seems that's all. I would like to thank you. If you will have any other questions, I'm here. So thank you. Bye.